Hi, good morning, everyone. I really appreciate the opportunity to present here today. My name is Trent Tinker, and I lead the federal team at Cesium. A little bit about myself. My background is in geospatial software development. I still like to consider myself a developer, but I found that it is a muscle, like a muscle. If you don't use it, you lose it. And let's say I haven't been to the gym in a while, but I still love to drive technical conversations. I spent most of my career working for geospatial product companies. I did step away and joined OGC, the nonprofit, and supporting their mission. And then about 2 years ago, I came back to industry and joined Cesium, and I'm super excited to be at Cesium, helping advance the 3D geospatial ecosystem in the DoD and the IC. As far as the presentation today, I'll give an introduction to Cesium, who we are, what we do, and who we support. Then we'll talk about the TAK 5.5 release and why we're so excited about this new release. And then lastly, I'll wrap it up with some Cesium updates that are relevant for the TAK community. Before I jump into the presentation, maybe just a quick question for the audience here. Who is familiar with Cesium already? All right, good show of hands there. And how about 3D tiles? Who's familiar with 3D tiles? Perfect. And has anybody used 3D tiles in TAK currently? All right, still a few hands. Perfect. I appreciate the feedback there, and definitely will be able to talk 3D tiles and TAK a lot more and show you what's possible in this presentation. All right, so who is Cesium? We started in 2011 with a company called AGI, and we spun out as our own company in 2019. And then recently, just last year, almost coming up on the year anniversary, we were acquired by Bentley Systems. Our number one goal is advancing the 3D geospatial ecosystem, and we do that through our core tenets of openness and interoperability. So on the openness side, we have our open source clients. These actually have over 12 million downloads globally. So for those of you who didn't raise your hand knowing Cesium, you've likely interacted with Cesium if you are using a 3D map. We started out with Cesium.js back in 2011. That's our web version, doing 3D visualization in the web. And then recently we've also added plugins for the gaming engines. So taking all the hard work that we've done in geospatial with accurate geospatial data and then pulling that to gaming engines. So we have open plugins for Unreal, for Unity, and for Omniverse, kind of sitting at the intersection of geospatial and the graphics world. What I really also want to call out here, often overlooked, but is Cesium Native. Cesium Native is also open source. It actually sits underneath the gaming engines as a common library for being able to pull in 3D tiles data. It's a C++ library, and it can be used with any other visualization where you need to connect to and pull in 3D tiles data. And I'll tell you a little bit more why that is relevant for this presentation in just a minute. So as we were developing these clients, especially with Cesium.js early on, we saw a common need to be able to pull in massive 3D geospatial data sets. And at that time, there really wasn't a good way to do that, a good open way to be able to efficiently stream massive 3D geospatial data sets. So in 2015, we created an open standard called 3D tiles. And then in 2019, that was adopted by OGC, the Open Geospatial Consortium, as a community standard. It is a community standard for streaming massive geospatial data sets. So think imagery and terrain, but also LiDAR data, photogrammetry data, CAD BIM data. 3D tiles is the format that you want to use there, and it's been widely adopted throughout industry and government. We are here talking federal, but I have to share some of my favorite use cases where you may have seen 3D tiles and Cesium on TV if you watched the Olympics last year. 3D tiles was streamed with the Google Photorealistic 3D tiles data, and then NBC Sports used Cesium for Unreal for part of the visualization. Now we've also seen that with NFL broadcasts with Fox Sports and also the Premier League. So it's really great to see geospatial and 3D coming to those groups. And then Cesium Ion is our commercial product for tiling and streaming 3D geospatial data. We have a SaaS offering where we host that in the cloud for you. And then we also have a self-hosted product, which primarily the customers in the DoD and the IC work with, where you can deploy that locally disconnected or on high-side networks. That does include a 3D tiling pipeline. And then as you see here on the screen, we also have curated 3D content, including a Cesium world terrain data set. So that's a high resolution data set for the world that is production ready that you can use. And then you can bring your own higher resolution insets and tile and stream it with those data sets. We also have a bathymetry data set and a few more, which I'll show on upcoming slides. So just a quick recap, Cesium Ion is the commercial side of Cesium, and then 3D Tiles is an open standard we created, and then we have our open source clients, which are used widely throughout industry. When we talk about supporting the 3D geospatial ecosystem, these are some of the logos as far as products and companies that are using Cesium currently, with a lot of the federal use cases here on the right side of the screen, including, of course, the TAK Product Center. And then commercially, within federal, the U.S. Army One World Terrain is one of our biggest 3D tiles users. That program has really helped also drive the 3D tiles roadmap. Some of the features that we'll talk about that are now available in TAK come directly from this program. NGA is also using Cesium Ion for tiling data in the map of the world. We have an OTA with NAVC for roadmap aligned services for advancing 3D tiles and Cesium JS. And then the 513th is also using it for tiling and streaming data for training and operations. All right, so with that introduction, we'll transition over to TAK and specifically the TAK 5.5 release. So earlier I mentioned Cesium Native. That is the open source C++ libraries for being able to pull in 3D tiles data. That has been in TAK supporting 3D tiles 1.0. And now in the latest version, TAK 5.5, you can now pull in 3D tiles 1.1 data. I'll talk a little bit more about why that is important, but I did want to note that that is included in TAK kernel. So special thanks to Chris Lawrence and the team with the TAK Product Center who integrated in Cesium Native into TAK kernel. And now that capability is going to be available in ATAK, in VRTAK, in TAKX. So really happy to see that, that capability there in TAK kernel. So why is 3D Tiles 1.1 important? There were some major improvements that were made in 3D Tiles 1.1, which came out in 2023. Starting out with metadata, being able to embed the metadata into the textures of the 3D Tiles data. As you see in the top screenshot there with the different coloring, in addition to visualizing more like your photogrammetry type of data, you could also style it based off of material properties. So that was one of the major improvements. It also includes implicit tiling. And so what does that mean? With 3D Tiles 1.0, if you got a massive data set, you needed all of those tiles referenced in what is the tileset.json root file, and that file then became very large. With 3D Tiles 1.1 and implicit tiling, you can just talk about the spatial indexing that you're doing, the extent of your data, and then you don't have to reference all of the individual tiles, it's just implied. So that really improves the usability of the tileset.json and really the support for those massive 3D 3D data sets. And then we've also really fully with 3D Tiles moved to GLTF, which is out of the Chronos group. So now really standardized on GLTF versus some of the other standards that were used in previous versions. So increased usability and increased performance in 3D Tiles 1.1. So what does that mean for you as a TAK user in 5.5? You can now easily integrate existing data sets. I've specifically called out here the One World Terrain program and the well-formed format, which is an extension of 3D Tiles. But there are certainly many other government available 3D Tiles 1.1 data sets that now you can pull into your TAK 5.5 release. If you're at the tactical edge and you're capturing some of your own data, say with a drone, you can take those high resolution insets, tile them in 3D Tiles 1.1, and then combine that with your other data. Here you see kind of some lower resolution data from TAK in the background, and then we've dropped in the higher resolution inset there as well. So if you haven't used 3D Tiles in TAK, just a quick screenshots on how that works. You can see here you interact with the map layers and then add a new data set. You can then point to the URL where the 3D Tiles is hosted. So with TAKServer and a few other recommendations on the 3D Tiles documentations in TAK, you can connect to any service there that is streaming the tileset JSON file. And then it'll identify the layers that are available and you can pull that into TAK. And then VRTAK, you can do the same thing. In VRTAK, you can also connect directly to Cesium Ion SAS or a local 3D Tiles data set as well. And then from a data formats support, currently TAK supports terrain. So think about your elevation data draped with imagery over top of it. And then it also supports photogrammetry data sets as well. And so what I'll do on the next slides is talk a little bit more about 3D Tiles, and because Cesium native is included in TAK kernel, what is possible from a roadmap perspective looking forward. So as I mentioned, 3D Tiles is an OGC community standard, and it's a standard for streaming massive 3D geospatial data sets. Here you see a mixture of some of the data sets that are supported with 3D Tiles, from OSM buildings to LiDAR data to photogrammetry data to weather data like voxels to your trees. And this does support, you can have a global data set of high resolution data, or smaller high resolution data sets and everything in between. A little bit of a look at the history. As I mentioned, we created 3D Tiles as an open standard in 2015. The first version was released in 2019. It did include a couple of different data format types as far as the payloads for how data was delivered. In 3D Tiles 1.1, we then standardized on GLTF, included the implicit tiling and the metadata. And then we have quite a lot in progress as well, and I will walk through some of those new exciting updates here on the next few slides. So first is with 3D Tiles, we did add now support for non-Earth ellipsoids, and we do offer a Cesium moon terrain data set now as well. This is a complete 3D Tiles data set of the moon, and there have been some fantastic use cases with this data set, especially with Unity and with Unreal for doing simulations on the moon. Real important for this community is we've also added in GPM 1.2 support into 3D Tiles. This was in collaboration with NGA and with Maxar on the One World Terrain program. So GPM stands for Generic Point Cloud Model, and essentially it allows you to embed the horizontal and vertical accuracy and uncertainty directly into the meshes and the pixels of the 3D Tiles data. So if you've worked with GPM in the past, it's typically a sidecar file in addition to your regular data set. So now that's been integrated directly into 3D Tiles so that you have that access to the accuracy. With 3D Tiles, you can do the styling client side, with the metadata, and that's what you're seeing with some of the shading in the screenshot here. Actually, I think this is a video, so let's see if I can play it. There we go. So here you can see using that, the GPM data where you can style all of the data, and you can also click individual points and see the individual values of that metadata that's embedded into the 3D tiles. A hot topic right now is Gaussian splats. This is an alternative to your typical photogrammetry processes where it really gives you fine-grained access. So think about trying to model a power line or a tower as shown in the screenshot here. Gaussian splats really allows you to preserve that fine-grained accuracy. And Gaussian splats is something that we've included in 3D tiles now as an extension. And in our products for being able to tile that data into 3D tiles as well. This picture really provides a good summary if you're not familiar with Gaussian splats. On the left here, you have the Gaussian splat of the tower, where you can see it's very accurate and all the wires and pieces are preserved. On the right-hand side, you see the mesh, which is the typical photogrammetry type of processing, where you lose some of that accuracy. So we're really excited about the future of Gaussian splats and the ability to bring this to the 3D tiles community as well. So as part of that support, we've worked with the Kronos group and GLTF for first an extension with GLTF for Gaussian splats, and now have also brought that to 3D tiles. Voxels is another hot topic right now. When I think voxels, I think kind of if you're familiar with NetCDF type of data or weather data, similar structured kind of format there. And voxels is something that we're also supporting now. I've got a couple of use cases here dealing with underground data. Also weather data. This is showing sea surface temperatures. We've also done some work with satellites with kind of density and heat maps with voxels. And what is unique about the implementation here is it's not just your traditional box implementation, but also cylinder and complex shapes as well. And then one of the things I'm super excited about is the time dynamic 3D tiles. So this is something that is in the works now. Imagine you have an existing 3D tiles data set for your area of interest. You then fly a drone or you capture new data. Rather than having to have a complete copy of the entire area of interest for your newer data set, time dynamic 3D tiles allows you to just visualize and store what has changed. So the way 3D tiles is structured, each GLTF node will have a temporal aspect to it, and then you can visualize that change over time with the time dynamic 3D tiles. So we originally started this with Earthworks, with the scenario that you see here, and really excited to eventually bring this to the TAK community as well. So just in summary, currently in TAK 5.5, you can now pull in the 3D tiles 1.1 data. That includes the terrain, so elevation data and imagery combined, and your photogrammetry data. But now that kind of seed and that capability is there at TAK kernel, and we look forward to working with the TAK Product Center on some of the additional capabilities shown here and bringing those to the community as well. It is worth noting, I know with WebTAK, Cesium.js is often used with WebTAK as well, and I did want to specifically call out that you can now drape imagery over 3D tiles as well. What you see here is the Google photorealistic 3D tiles data with a 2D imagery layer from Google draped over top of it so that you can also see the roads network. So this is a capability that you can also do as pulling in the latest version of Cesium JS to those WebTAK implementations. So some relevant updates from Cesium for TAK. So kind of another summary slide of what we just discussed. You can pull in a lot of the existing kind of data sets that are out there, like One World Terrain, like NGA Grid, TAK maps. You can now pull in that 3D Tiles 1.1 data into your TAK products. And then with Cesium, you can also combine your own data with those data sets. So whether it's just drone images that you've captured, and I'll show how you can get those into 3D tiles, or if you have your own 3D data. So say you've got a bunch of DTED data or DIM files, hundreds of files that you want to tile and combine with an existing data set. With Cesium Ion, you can do that. You can tile your data, and then you can combine it with some of those existing data sets that are available as well. You can do that in the cloud where we host it for you, or you can do that in your own disconnected or high-side network. This is part of the collaboration now being a part of Bentley Systems. One of the things we're really excited about there is just the integration of technology. Here you see where you've flown a drone. You can drop those images into to Cesium Ion. This is going to give it a name. And with the integration of the iTwin capture capability from Bentley into Cesium Ion, you can now, with just the easy clicks that you see here on the screen, drop those imagery files in, and it will automatically create a photogrammetry data set, a Gaussian splats data set, and a LiDAR data set from your images. So really excited for this new capability in Cesium Ion. Once this 3D tiles data set is available, of course, then you can pull it into TAK and visualize it as we are showing here. As I mentioned, there's also a 3D tiling pipeline. So if you have your own imagery, your terrain data, your photogrammetry data, like in OBJs, you can pull that into Cesium Ion. Use our 3D tiling pipeline, which is really focused on compression, so reducing the size of the data set, and then also performance as far as being able to stream that data efficiently to your client applications. This is one that we often get a request for. So imagine you have an enterprise server and you want to clip out a particular area of interest because of just size and storage constraints. With the clip and ship capability, you can start with your massive, say, global data set, and then for your particular area of interest, you can draw a box. You can then export out that 3D tiles 1.1 data set. And then pull that into your TAK device for visualization. This is an example of clip and ship that I did for this event. We have a data partner, Vexeld, which provides high-resolution photogrammetry data for offline use cases. In the top screenshot here, you can see the box where I actually clipped out a much larger data set. And then as we're zooming in here on the hotel where we are, you can see that higher resolution 3D tiles 1.1 data. And these are types of rich data sets that we're really excited to bring to the TAK community with the 5.5 release and the integration of Cesium native. And then yeah, just to kind of wrap things up here, Cesium Ion self-hosted is, it's delivered in a Docker image or Kubernetes where you can deploy that in your own local disconnected environment, do everything that you saw on the previous screens here. It does use Iron Bank container images, so extremely secure and ready for your high-side deployments. And that's Cesium Ion self-hosted. And with that, I'll wrap up and pause for questions. Do you want to?
Just a quick one. Do you have any plans for like RF modeling or RF integration with all this map data? Or
That's-
is it relying on like external tools?
That would still rely on some external tools. So definitely 3D tiles data is ready for RF channel modeling, especially when you think about like material properties and how important that is. And we do have some of our partners and customers that do RF channel modeling where they've pulled in the 3D tiles 1.1 data, utilized the metadata properties for the material classification, and then they're able to do that. But that would be outside the scope of something that we can do. But we do have a couple of partners that'd be happy to discuss with you.
Kubernetes KAs?
Yes.
Where are you guys on your Kubernetes packaging?
That is a good question. That I'm not sure. I forget the names of the packaging there, but I know with the Iron Bank container images, there's a lot of work done there as far as secure, but I'm not sure of the exact packaging there. But it is ready for high side deployment and IL6 deployment there. Any other questions? All right, appreciate your time. Thank you.